So, on direct variation, we have on number 1, y varies directly. You're going to look for those words. It's either going to say jointly, directly, or inversely. We're only dealing with directly now. So y varies directly as x, and y equals 9 when x equals 6. So y varies directly with x, and y equals 9 when x equals 6. That is your complete set of information. You have one y and one 6 and one y and one x that go together. Then it says find find y when x equals 8. So this is a basic proportion. I'm going to show you how to do it this way. I'm going to show a method 2, which is the way they want you to do it, but I don't care if you do it either way, okay? So what I do is I have y varies directly as x. So I set up a proportion like this. Y varies directly as x. You have y's and you have x's, right? If you have p's and d's, and you got p's and d's, x and z's, whatever. And then y equals 9 when x equals 6 go across from each other, because those two go across from each other. Do you understand that? And then it says find y, so I'm going to put a y here because I don't know it, when x equals 8. Everybody see how I set it up? So it sets up as a proportion. When you have two fractions equal to each other, you cross multiply. So we have 72 equals 6y. So y equals, what is that, 12? Method 2, the equation of a direct variation is y equals kx, where k is a constant. Okay? So you have to know 3 equations when you're doing a direct, joint, and inverse variations. You have to know 3 equations. Y equals kx is the one for direct. So we use the complete set of information right here to find k. So we know y is 9 when x is 6. Now, is it easy to find k? Yeah, just divide by 6. And k would be equal to 3/2. All we have found here is the constant. So we write the equation as now y equals 3/2 x, because we use this equation up here, and we just plug in the k that we found. And now it says find y when x equals 8. And so y equals 12. When you multiply 3/2 by 8, you get 12. All right, so if y varies inversely as x, and y equals 12 when x equals 10, find y when x equals 15. Method 1, we can do a proportion, but you have to remember to do something first. So we have the x's and the y's, or the y's and the x's, right? Just like before, we set up a proportion. And we have y is 12. Your complete set of information is 12 when x is 10. Find y when x is 15. But before you're going to cross multiply, you have to rewrite it and flip the second fraction, because it's an inverse proportion, so you have to flip it, okay? So when you flip it, now you can cross multiply. You have 120 equals 15y. Divide by 15, and I think y is 8. Somebody check that for me. Method 2, we've got the equation for an inverse variation is y equals k over x, because it's inverse. Remember, we flipped the guy? That's why the x goes downstairs now. So we can use the complete set of information, which is this right here, right, in order to find the k. Y is 12 when x is 10. So k over 10. Got it? And how do we leave the k alone? We multiply both sides by 10. So k equals 120. Does everybody see that? And now we put k into the equation. Y equals 120 over x. And we use our incomplete set of information. Find y when x is 15. So y equals 8. Either way, you get the same answer. Now let's talk about the difference between an inverse and a direct variation. An example of a direct variation in real life would be if I work 30 hours a week and I make $400, how much will I make if I work 35 hours a week? Okay, how much will I make? That's a direct variation. The more you work, the more you'll make, right? It's directly impacted as one rises, the other one rises. So you have 30 is to $400. This is hours and dollars. Like 35 is to x, and you just cross multiply those and you find the x. So what's 30 times 400? 35 times 400.
I need charges.
1400 equals 30x, I believe. Somebody check that for me.
Let me see.
It's 14,000, and then you divide that by 30. What is 14,000 divided by 30?
14,000 divided by 30 is 466.666666.
Okay, so in money, they would round to the nearest penny. Other examples of direct variation is if you need 2 cups of flour to make 28 cookies. How many cups of flour do you need to make 200 cookies? You can figure these things out with direct variation. Okay? An inverse variation, an example of an inverse variation is, let's say it takes Will and Miss Medlin 6 hours to shovel the driveway. What happens when we add another person to help us? What's going to happen to the time?
It should reduce.
It should go down. That's an example of an inverse variation, okay? So we're going to add another person. So now this is how it works. You have people and you have hours, okay? If 2 people take 6 hours, how many hours will 3 people take, right? But what do we say about an inverse? What do we do first before we cross multiply? On an inverse, we flip this guy, right? So now we have 2/3 equals x over 6. So 12 equals 3x, and it will take 4 hours for 3 of us to shovel the driveway. Does everybody understand that? That's a good example of an inverse variation. The more people you add to a job, the less time it takes. Okay? A lot of examples about inverse variations are painting a house, doing some kind of construction, doing some kind of work, where you're adding people to the job.